Hey guys, so welcome back. Okay, so it's been a little bit of time since I repaired this, and so the next question is I got to talking with the owner about the uh, the issue with the transformer. If you remember, the transformer looked like a lot of tar had leaked out of it, but the other side of it was that there was a capacitor inside the transformer. I'll pop it up here on the screen. So when this was recapped, I don't know if that capacitor that's in there was replaced. I'm going to actually assume it probably was not. So, partly because the tar leaked everywhere and it doesn't look like it had been cleaned up or that the transformer had been removed. So this is a classic, risk-reward deal of, do we go in there and see if we can get that transformer off to see if that old capacitor is in there so that we can take that out. Now, operation-wise, the radio seems to operate fine, but if we can get the transformer off, it'd be nice to see if that capacitor is there. Maybe we can change it. So what we've agreed to do is that I'm going to open this thing back up and go after that transformer and see if we can get that out. I'm going to go in there and kind of pick at that tar and see if I can get it loose. But if I think that it's going to get to where I'm going to possibly damage this radio, I'm going to stop and just say, hey, it's working for now. We'll see what happens. If something goes wrong, there's a fuse in the line, it'll save it. So that's what we're going to do in this episode. We're going to take this thing apart and go after that transformer and see if it'll come loose. Okay, let's open the other side. Okay, so if we look over here, we'll see the situation with the tar down here. Let's zoom in there. So our challenge is to see about getting this transformer off. Now there's like a hole here. Let me get this cover off here. Okay. So here you can see the way the situation. All right, so I get something to point with here. So this we know is not factory. Okay. This shows tar leaking out from where the transformer is. And this capacitor here is attached to a screw right down here. You see it there? It's a screw right there. Well, there's actually three of them. There's one here. There's one right here under tar. And the third one is here, also under tar. So we're going to have trouble getting those three out. I think those have to do with holding the transformer in place. We'll see how it goes. Now we also have holes here and here where the lines from the transformer come over to this side of the chassis. And there may be something here too. Something here I think has to do with the way the power comes in and this kind of chassis capacitor here. So we got some things to try to figure out in here. But the main thing is can we get the tar loose, or do we just say we can't get it done? So that's where we are. That's what we're going to start with. Okay. Okay, it seems to be coming off of here okay. Alright, so that's a good move. Let's see if this will budge, this little noodle. Yes, it does. Okay, this is going a little easier than I thought it would. I thought this would be really hard. Okay, let's see what we have going on here. I'm getting kind of encouraged. I thought I was going to have a whole lot of trouble with this. See what I'm doing there? Yeah, okay. So the way those screws go down in there, if there's tar on the back side of those screws where the threads have to come up through the chassis, well, we'll have to see how that goes. I was thinking maybe what I'd have to do is heat up the head of the screw, but you know, the way this is, maybe it's not going to do it. Maybe it'll be okay. I'll have to mark these wires off to where they go and then disconnect them and get to where maybe I can feed them back through, but I'll see if I can get the screws out. So it's actually going pretty well, I must say. Again, we made a lot of good progress here. You know, I'll clean this up later. I know I can clean it with WD-40 or lacquer thinner, but I'm not going to worry about that right now. What I've done is I've exposed each of these 3 screws to where I can give them a try. Okay, there's 1, 2, 3. I was able to clean the tar off this plate and get to where I was at the sharp edge of the hole that the wire comes through here and here. I haven't done this one yet. I need to look into this, see what's going on here. But one of the things I'm going to have to do is disconnect some wires so that if I do get the transformer loose, I can pull it, you know, pull it out. So I've got 1, 2, 3, 4, 5. Is that right? We'll double check, but I'll make sure that they're all labeled as far as where they go. I know they're supposed to be color-coded, but the colors are kind of hard to read anymore, right? So I'm going to get those labeled, and then I'll be picking at this. I'll bring you back after I've made some progress. Okay, so what we have here is we've got, out of the vibrator, we've got a black and a yellow. Going to the plates, we have a brown and a green. And going to ground, we have red with a black trace. Okay, and then there's a yellow lead here where the power comes in. So the power comes in up here. There's a lead in there, I think, but I can't see it very well. It's stuck in the tar. But that would be the one by itself, and that's the yellow, apparently. Okay, the ones that go to the vibrator are black and yellow. Well, what I've got is I've got 2 blacks. I don't think it matters which one is which. I'll make it to where I got like a you know, I'll make some way of marking which one's which, so make sure I put it back in the right place. I don't think it matters, but I'll do it anyway. Then I have black, green, red, black. What am I saying? Brown, green, red with a black trace. Okay, that is here. We've got a brown and a green. You see that's brown, that's brown, that's green. This doesn't go into the transformer, that goes a sneak back behind here. This is red with a black trace, and it comes out of the transformer here, ties to this pin, and then it's tied to ground right there. Alright, so there's my leads. 1, 2, 3, 4, 5, 6. I'll get those disconnected. Okay, so I got the, these are the two leads that go to the vibrator. I got them done. The one with the bend in I've got going to this location here. The straight one goes down here where the straight lead of the resistor went. Over here I've got these leads twisted together so they stay. Here's the brown and the green. Then here's the red with the red trace. That took a lot of work to get it off that ground because it's part of the chassis. And then this was a lot of work up here. The connection between this wire, which I believe goes into the center tap, and here was a very tenuous connection. It didn't look like very solid to me, but anyway, I think I've got that loose. The connection looked like it was just something about like that. Anyway, now I think I've got all of the leads to where they can be run back in through the holes. I'm hoping. So these screws, I've given them, I got onto them with a nice pair of nut drivers, held in there really tight and popped them loose. They're all three of them are loose now. So let's go ahead and get them off and we'll see what happens next. This one has the little added capacitor stuck underneath it. So that little Chicon negative went to there, of course. Okay, there's one. It'd be nice if this just came right off. I'm not going to jinx it. Like I said, I already had these loose. Okay, those three are off. Okay, I think I've got all of the tar out of the way of the holes. Let me check this one real quick. I'm going to try pushing through this hole here. It's loose. I don't believe. Okay, I'd rather be lucky than good. Let me back up. Okay, we need to feed these wires through carefully. And here it comes. Good grief. Transformer is coming out. And there we are. Okay. Now what? I don't know how this is made. It looks like the bottom is crimped on here, and that is what is the bracket that holds it in place. So what I'm going to do is take some time and clean the top of this all off and then see what we have then. I'll bring you back when I get that done. Okay, so I've done some digging around, cleaning the tar off most of the plate here, cleared up around the holes that are going into this. So this plate, which is what crimps onto the outside of the can, is not what these holes are in. There's another plate underneath. If you can see that, see there's actually another layer there. So this is part of another layer down below, these three holes at the tapped holes. So this plate here is on top of that. So I guess the thing to do would be to uncrimp this and try to separate this top plate off. Now as I've gone through and tried to clean up the tar in here, one of the things I've been able to see is I can get in there and I can actually see part of the windings in there. So there's not a lot of tar in there. Okay, so the next thing to do, I've gone through and I think I've opened up where these wires go through. This has not got a very long lead. That kind of annoys me. This is the one that'll have the capacitor on it. So I guess the next thing to do will be to uncrimp this and try to slip this off. I'm not going to have you watch me do that, I don't think. So anyway, here we go. The seam of the can, if it matters, is located in this position. So as it's looking at you going, oh no, the seam is right here at 9 o'clock. Okay, kind of looks like a bear, doesn't it? Okay. So I thought before we tried to open this up, we would make some measurements now that we have all of the leads lifted to see what the characteristics are between the different leads. And one of the main things I was wondering is that could we, now that we have the leads lifted, before we even took it off the chassis, would we be able to tell whether that capacitor is in here or not? I think we probably might be able to. We'll just have to see what's what. So what we have is, let's go back to this, right? So we should be able to see the impedance from the center tap, red-black, to one of these leads here. So let's see if we get that. Go from here. Okay, so if we go from red with a black trace here to one of the leads on the secondary, yeah, that's in K ohms, okay, so that's 400 ohms. So what we're doing is we're checking, what is that, the brown? So we're going from the center tap to brown. And we can check the other one, won't be identical, but it'll probably be close. Yeah, 384, that's K ohms, 384 rather, ohms, and that's from the center tap to the other side. Okay, let's check the primary side. Red to yellow, or whatever they call it. Black to yellow, which is black to black. Yeah, we're getting 0.3 ohms here. The center tap will be this lead that comes in. Let's see what we get there. Yeah, it's very little. Yeah, it's very little. Now, one of the things I was wondering is red with a black trace grounded inside the grounded inside the case. So let's see, there's red with a black trace, and let's go to the case here. Let's see. 0. Yep. Yeah, I'm not getting any continuity to the case, so this doesn't seem to be directly grounded inside of here. So let's see this yellow lead coming in, see if we see ground here. That'd be here to here. Okay, we're getting 3 megohms. That looks like maybe that capacitor there and it's leaking. Because what we're doing, right, is we're going from yellow in to the chassis or the case, right? And we're at 5.5 megohms. So let me get my component tester out and let's see if we can see something there. In case you're wondering, I just have like bits of old resistor lead stuck in there. Okay, that's to the case of the transformer. And this is to the power lead that goes in. Alright, so I'm connected between this yellow lead coming in and the case. Let's see if we can see something here. Holy cow, there it is. Capacitor. It's in there. ESR 16 ohms and it's 140 microfarads it measures. It's supposed to be 0.5 microfarads, so yeah, that's leaking. Alright, then I guess we do need to go in there. There's a capacitor in there and it leaks, so we've got to get it out. Okay, let me clear all this out of the way so I can start working on getting this lid off. Okay, let's see how this goes. Okay, I think this is going to work. It's just going to take a lot of patience. I'll bring you back when I get this done. Okay, I've got it almost off. I've gone all the way around. It's like this can is rolled over and the lid is kind of rolled over with it. So in some cases it comes up together, in some cases they separate, and we'll just have to see how it comes out. But anyway, I'm almost finished. I thought I'd have you on while I'm get it finally opened up. So let's see if it'll start to move. I don't want to bend it. Hoping it'll come off without having to do heat and all that. So it's kind of set down in there. So this hasn't been opened. It's 70 years. Side cutters are good for this because the steel is hardened, as opposed to like a a screwdriver blade like this isn't really hardened. Not like this is. Okay. Any sign of motion here? Well, it's not just flying out, I can tell you that. It's going to take some work. I'm either going to speed you up or jump you forward. We'll just see how it works. We're in. Okay, let's look at this together. Oh, it is coming with it. I thought these would be separate. Hung up on this, around this lead here, the corner. Oh, there's a lead soldered there. That's what that is. That's the ground is soldered here. Okay. See if I can leave that kind of be. Okay. So there's the secondary windings out. You can see the nice mess we have here. Okay. So what we have here is we've got the power lead as it comes in, which is that center tap, and there's a lead that comes up and is soldered to it there. I don't know if I should unsolder it. I probably should. There's your transformer in there. There's definitely some tar. Do I see it? Is that it right there? There it is. There is the capacitor right there on top. I don't think I'm going to be able to say, oh, I don't need to take it out of the can. I'll poke around, but I don't think I'm going to be that lucky, because apparently there's a coil in here that it goes to before it gets to the capacitor, so I'm going to have to do some poking around at this. When you come back, I'm going to have some of this poked out of here, and I'll be figuring out what I'm going to do next. I might just go ahead and unsolder this so I get a little bit of room to work. I might break it off anyway. No sense putting stress on it. Let's see, what would I want? What do I want to do here? If I take that capacitor out, does that mean I'm going to ground this? No, I don't think so. So I don't want that ground there anyway. What I want to do is cut that ground, and I want to cut the other side of the capacitor, and then I'm done. So I'm going to put this capacitor outside, right? Let's talk about this before I go much further. This may not have to do as much work. Okay, so what do we want to do? Do we want to take this capacitor out? Yes, we do. Do we want to replace it? No, we don't. Now, you say, well, maybe you do, because look, you know, you've got a capacitor here, and you've got another capacitor here. So if that's a coil, you've got a pi network here. You've got a first capacitor, you got a coil, like a choke, and then you've got another capacitor that goes to ground. So it's kind of a pi network. Do you want to get rid of that? Well, the alternative is put another capacitor in here. I don't think I want to do that. So I'm going to take the capacitor out, and I'm not going to worry about that. I may put that big Chicon back out here where it was, and hope that provides all the filtering that's necessary. This one here I don't think is doing much anyway. So we're going to, so what does that mean? That means I can cut this lead and cut that lead. I can just remove it and not connect to the chassis at all. If I do, it'll short, right? So I just clip out the capacitor and we're done. I may not even have to take it out of the box. Okay, well, let me give that some thought and poke around at it, but that might be our course of action. There we go. Good. That was not a big deal. I was wondering which one of these was which. Wrong side. Okay, so this bare lead must go to the capacitor directly. Let's just start doing a little digging. You know, I have to unpot this. Huh. Actually, it's broken. I think it's broken. I think it's broken. Doesn't matter, we're not going to need it anyway. But it's broken loose from that capacitor. Okay. What's going on over here? What I like about what we're doing here is we might not, you know, be putting less stress on the coil and the wires coming off the windings. So the other end of this capacitor has a lead that goes to the center winding of the primary. And what I want to do with that is just cut it and I guess insulate it. Probably just put some shrink tubing on it. Okay, I see the other wire coming out of the other side of the capacitor. Will it budge? Yeah, it'll budge. Come on out of there, you. Come on out of there, you. Come on, we want you out. You need to come on out. So there's the end that was broken off. And there it is. Yeah, it's like the end of it was popped off. Okay, so the other end of this, let's see. So what we had was, good grief, look at this. That was either here or down in there. Yeah, again, it needed to come out. Okay, I think we got that side okay. If there's another coil in there, I don't think it matters. I don't think we need to worry about it. I want to get some light in there so we can see a little better. Hold on. You won't be able to see as well as me, but I got to see a little better. Okay, so that other end, let's think about this. This other end should go to the center tap between these two wires here. All right. Those two wires are these two wires here. And that lead, we just took that capacitor out of there. So we should have a lead that goes to the center tap, and it should join up with the lead coming in. And all I want to do is terminate that where it won't short out to anything. See, that's the other end of that capacitor right there. Can you see it? Right there, it's like a disc. I mean, I could pull this out, but I don't see any reason to risk doing that because I might damage it pulling on the leads. I mean, in reality, I think all I have to do is cut this, insulate it, and close this thing back up. And it should be okay. Because I believe all that we were looking at there, right, is we were looking at that piece of wire that's right here. And I can just cut that anywhere and insulate what's left, and then I have continuity from here into the center tap. We just checked that. Right. Okay, let's see if I can show you what I'm looking at here. So that wire you see right there is the wire that went to the capacitor from the center tap. And that cap you see there is where it was attached to the, is the end of the capacitor basically, right there. Okay, so as you can see, it's a bare wire. What I'm going to do is I'm going to cut it. That whole area is surrounded in tar. I'm going to cut that, and I'm going to slip a piece of shrink tubing over that and shrink it. And we're going to call that done. And then what I'll do is I'll hook up the leads, and we'll see if we can test the transformer before I put it back together. Now you may be saying to yourself, you don't need to put shrink tube on, just cut it. Make sure it doesn't touch the side. Well, it's true. That's true. I'm going to do it anyway. Okay. Okay. So there's the end of the capacitor. Okay. Stick shrink tubing over it. There we go. If it's a little long, it will not matter. Probably make a little bit of tar flow here, but not very much, hopefully. I'm smelling tar. Okay. Right. That's not going anywhere. Everything's black in there and it's kind of hard to see anything. I'm trying to show you the best I can. So you can find an angle. Well, anyway. I think that's that. Okay, what I want to do is rig up stick it into that wet tar. There we go. Alright, I'm going to rig up a test and we'll make sure the transformer still works. Okay, I got this wired up to test the transformer. I'll go through the wiring here just briefly. So I've got the isolation transformer back here, my variac. I've got the DC power supply over here. I'm going to be measuring DC volts here. That's coming from the power supply directly as it goes into what we're testing here. So this will be direct DC volts. I can get that set right. Yeah, it's on DC. Okay, this will be measuring the output voltage of the transformer. I'll show you where that is in a minute. This is showing the DC amps that are going through the line into the system we have set up. Okay, so where we are with this is we do not have the rectifier in there. Okay, so the rectifier is not there. We're back to where we were testing the transformer with nothing else connected to it. Okay, so that's out. I've got the vibrator in the chassis. I've reconnected this resistor here. I'm going to be bringing in power through the ammeter in through this line. Okay, and it'll go through here. It'll go through the vibrator. The vibrator will go to ground through the chassis. And the chassis does have the return on it to the power supply up here. Alright, so then the two leads here that go to the vibrator are these two here, and they go up here onto the vibrator right here. Okay, so that's what's going on with those guys there. Over here, this black lead is the out from the ammeter, if you will, to the power in, which is here. It may look like it's touching the cabinet of this, but it's not. And then this is where I'm measuring the DC voltage in. Okay, so over here are the two outputs that go to the rectifier. Now, this buffer capacitor, I wasn't sure if I needed it, so I took it out of the chassis and I went ahead and attached it here just in case, the solid state vibrator needed it. So it's back in there. It won't hurt the measurements. So what we'll be able to do is measure between these two. The other thing I've done is I've taken this lead, the red-black, and I've grounded it to the chassis. Okay, so let's look at that. Here's the red-black lead. Can't see it back there. This is the red-black lead here. And it goes up to the chassis here. Okay. These two white leads are the two, I won't be doing this again, are the two high voltage outputs in the secondary. They go to the buffer capacitor, which I've connected right here, and then I've got voltage probes on either side of that capacitor that we're going to be reading here. Okay, So I think we're set up to go. I've got the dim bulb in the circuit just in case there's something wrong. I'm going to be watching the current closely. I may end up bypassing the bulb, but I'll be watching the voltage. I'm sorry, the current here for sure. So once again, this is DC input in. This is the current going in. The DC input is right at the unit. And then this will be the output of the secondary of the transformer, high lead to high lead. So it'll be on the order of maybe 600 volts or so if we go to full voltage. But we'll still be in the hundreds of volts. All right, so I think we're ready to go. All right, so DC amps, AC. Okay, that's down, that's bypassed. This bulb is in the circuit. Okay, here we go. So this is voltage coming in. Let me turn my variac up to like about 110. Okay, this is down. We're on the 6-volt range. Let's go with this. Okay, we're at half a volt. Let's go and bring this up.
2 volts. 3 volts. Getting voltage out of the transformer. At a quarter of an amp. 3 volts going in, so here's voltage is in. This is the voltage out of the transformer here. Looks like it's working okay. Come on up. Half an amp. Now we don't have load on this, right? 5 volts.
Okay, I'm going to stop here. We're at 5 and the third volts in. We're at half an amp, and we've got 643 volts out of the transformer right there. Measuring it here, but it's coming off of those 2 leads. So I think we're successful. I think that the transformer is working okay. So the thing to do is just to put the lid back on it and install it back in the chassis. Before I put it in the chassis, I'm going to try to clean it up a little bit, make it look a little nicer. One of the big challenges would be to put the cap back on here and seal it up and, you know, make sure it holds on good. Okay, I'm ready to start putting this lid back on. I went through and kind of evened out the top a little bit. Okay, let's see, there's the seam, there's our face. Okay. All right. I'm not sure how to do this, so we're just going to start trying things. Let's just see what happens. I like the idea of this to wind it around, but I don't know if I can get a catch of it. See, like right there, I think I may have had a pretty good crimp there. If I can do that on a couple of the sides, we'll see how we do. It's down all the way. Okay. I think we're doing all right. Okay. I think we're on the way. Got several crimps in. I'm just going to work my way around. Bring it back after I get it done. Okay, we got the lid crimp back on. It's nice and sturdy. It is not coming off. I can tell you that. Crimped it down really hard, rotated them around, and then really smashed them under the bead all the way around. It's on there solid. This is never going to need to come off again. We've got that capacitor out of there. Great. Okay, so I've got in here and I've cleaned out all the tar that was all over in here Even some of it seemed like it had run up some of the lines and was up in here. So I got that all cleaned up. What the black is, I don't know. I've tried rubbing it off. It doesn't want to come off, but it's not tar there anymore, I guess. Maybe it's stain. I don't know. But we got the tar cleaned up. I went over the whole thing with WD-40 in through here, which does a great job of dissolving the residue that was there, and got that all cleaned up. So I want to draw attention to that little capacitor that's there that we were looking at earlier in the other episode. Okay, so this is obviously a rivet, and a lot of details about how this is assembled I really don't know. But I thought what we would do is we would check its capacitance. Now that I've got these other leads lifted off of it, we can see what characteristics it has. So let's take a quick look. First thing I thought we would do is let's see if it's got any continuity at all to anything. Let me zoom you in. Okay. So go here. Let's see if I touch it. All right, that's working. So let's go to the chassis here. Yeah, I'm getting nothing. No connection to any of the grounds. Okay, so there's no continuity there. Now let's check for what our component tester says about it. So I'll go from, got a decent ground here. This goes directly to a chassis ground solder point. We'll go here. So let's see what this thing is. Okay, it's a capacitor. 16 ohm ESR, and it's 114 picofarads. What is this thing? I'm not sure. I can't see that being much help in terms of the noise coming in. If you look at it in the context of this, so they're saying that is 115 or so picofarads, and then we come into here, and then here's that capacitor that we just removed out of the transformer. It's, by comparison, 5,000 picofarads, right? It's 0.5 microfarads. So I think what we're going to do is, part of the question is, what do we do about replacing this? I don't see this as doing, I'm sorry, I pointed the wrong one. I'm not thinking this, is doing much in the context of this. I mean, that's virtually insignificant. It must have a different function, maybe as a very high voltage spike. Maybe it breaks down and allows it to bypass. I don't know. If you guys know, I'd like to know. You might be speculating, but if you know, I'd like to know. Meanwhile, I think what I'm going to do is I'm going to take this 0.5 and I'm going to move it over here. I don't have a 0.5 on me right now. I'm going to experiment with some different sizes to see if they would work. What was in there by the previous restorer, they didn't, they replaced these capacitors through the rest of the radio, but they didn't replace the one in the transformer, right? Didn't even tell us they didn't do it. But there was some noise there because we tried disconnecting this and we heard noise. So they put this in to deal with the fact that that other capacitor wasn't working, but they didn't bother to remove it either. So it's like they basically put it across it. This is a 1000 microfarad 35 volt electrolytic. I'm thinking surely it doesn't need 1000 microfarads. I've got like some I've got some electrolytics that I could put there, or I could order a film capacitor to put there. I may experiment with some different things to see what difference it makes. But anyway, I don't plan on putting this in. I just think that just seems like something they had handy and they just stuck it in and it worked. Okay. So the other thing I was thinking about doing is I have test fit the capacitor, and it fits into there just fine, obviously. Okay, the areas where I left tar behind on the other side, this just fits right into those spots. It's not a problem. One of the questions is do I need to ground this case, because there was a ground lead here that went to the other side of the capacitor that was in here. Well, it did not have otherwise any other connection to the ground. Okay, so I'm thinking that it gets ground through the screws that go into here and thread into here. Okay, so that's obviously giving it a good enough ground. One of the things I'm thinking about doing though is if I put a bypass, noise suppression capacitor here, is where am I going to get ground for it? There is a ground, like I say, it's behind here where this goes to the chassis. But I was thinking what I was doing is maybe under the screws I put here under the transformer is put a star lug that has a tag on it and use that to be another ground location. That will make sure that the screw in here gets to ground on the chassis okay, and also give me a place to tie on the bypass capacitor that I put there. That's something I'm looking at. The other thing I'm looking at is how these here, it's so hard to see this, and it's so black, but how this goes through this chassis and whether or not it touches the side, and do I need to worry about it rubbing through. It's really held in the middle. It doesn't look like to me it's going to cause a problem, but I think what I'm going to try to do is try to see if I can fit these grommets into those holes. I think it's not going to interfere with anything. You can see how thin the grommet is where it comes up, and it's relatively small compared to the lip of this, so I don't think it's going to interfere. If that fits and it works, I'll put that in. Okay, so then the next step is I'll try putting these in, and then put the transformer in. I put the transformer in, and then I'll start making these connections back up, and then we'll start looking at I need to rewire these other things too, and then we'll start looking at different capacitors in here to replace the 0.5 capacitor that came out of the transformer. All right, so let me get that put in, and I'll bring it back. Transformer remounted. The grommets fit in there very well. They had a lot of room. They're quite flexible. I had to bend this one a little bit of room to make room for the screw. I've test fit the cover back on. It works just fine. I'm going to have to take this grommet and just push it over a little bit, and that'll fit, and that works just fine. This one right here was very cooperative. The wire from inside just came straight up, went right into the middle of that lug, so I bent it over. Got the other leads attached temporarily, and there you can see the star washer with a tag on the edge, and we'll try it out in that location on the edge, on the inside, which assures I have good ground contact between the chassis and the threads inside the lid of the transformer in case we need it. And that's where I'm going to try different capacitors to this point here. I think I got room if I want to put in a fairly large cap there, it'll fit. Okay, I am going to start reattaching these leads. Left some things loose in here. Get that all reattached and get this wired up. And then I think the next thing we'll be doing is bringing up the power to the system and trying out some different capacitances for noise level.
It's this political swampy.
Okay, so we've got this transformer rewired back in here. I've got power going to the radio.
We've got a lot
Radio's working great.
on our side.
And surpass their efforts.
But we've got a lot of work to do to clean up our
And
side.
so that's it's working really good. I've got the cover to go back on. Just wanted you to see how I've gotten all the wires redone. I got the capacitor back in. Got the leads coming back in. Be careful with my distance here. And I put a little note right down here that says transformer cap removed. I've also put a note inside of here that says the same thing. So that we know that if somebody comes in here 50 years from now, they'll know, hey, somebody's already been into that transformer, the cap's out, thank you very much, so I don't have to take it out and do it on my own. I've got the little tag in there. I think I showed a picture of it in the edit. I'll put it in there, show what that little tag looks like. And so what I'm going to do is try different capacitors out in here to be a bypass capacitor for that. So what I found is that I've got this one out. You can hear a little bit of noise there. Now, I don't have a 53 Chevy to hook this up to see what kind of noise is going to come from that. So basically, we're picking up noise from the shop that's being picked up by all these wires that are exposed and running around. I've got another one here that I have clipped to this tag on this spark gap capacitor, so that we can try different ones out, and basically the noise is coming off of the electronics in my shop being picked up by this antenna basically. But anyway, we'll just see how they work. It works best if I go onto a station that's not so strong. Let me find another one here. So let me go just off station, so the AVC is not pushing it out where we can't hear it. So here's this Chicon that was in here when we picked this up. There's no date code on this that I understand, so I don't know how old this is. I'm not going to use it, okay? But let's hear how this does in the noise. We'll use it for comparison purposes. So this lead here is the voltage coming in, so it'll go here. You can hear the difference when I attach that to the noise, maybe. Okay, now I'm going to touch it to the tag here. So you can hear the type of noise that it's removing. So let's try a different capacitor. Let's try a, let's see, I think I have one around here somewhere. What did I do there? This is a 1 microfarad capacitor at 450, but this is a 1 microfarad. So I'll ground out the negative side. So it does some good, but I don't think it does as good. So let's try, instead of an electrolytic, let's try a film cap. So here's the right spec. This is a 0.5 microfarad cap, 60 volt. Let's just try hooking this up. Well, that seems to do as good as the 1000 microfarad electrolytic. Now I have another one here. I have a this is a 47. So what I'm going to do is I'm going to put both of these together to simulate 1 microfarad with film caps. Okay, that should give me essentially 1 microfarad, right? See how that works. Let me see if I can get this. Hear the noise level? Just from the noise in my shop is what that is. Now that to me seems to really get rid of it just fine. I think either a 0.5 microfarad or a 1 farad will work fine. So that's good to know. Alright, what I'm going to do is I'm going to get different manufacturers of this. I want to get some that match my Cornell Dublier's ICs, so it's a good quality cap. It's a 6 volt line. I don't need to put 630 volts in here, but that's basically done. I'm going to put the cover on this, so when the other cap comes in I'll put that in, and I think we're just about finished. If you go back onto a station, the AVC pushes the noise floor way down, and you don't hear it. Even without the cap.
$1 a day. Find out if it can work for you like it works for me by ordering your 3-week quick starter pack.
Okay, so we got the new capacitor in. It's an IC, Cornell Dublier 0.47 at 50 volts, and we're doing good on the noise. So I think we can be happy with this.
Collected petition signature, process pricing, and
Proud home of your world champion, Houston Astros.
We got our tone control.
Sports Talk 790 from the CarBingo.com studios.
Well, guys, that was interesting. It's interesting. You look at one of these things, you open it up, and you see all those new yellow caps in there, and you think, oh, somebody's already recapped this. But you don't know whether they got it all done. And I don't know, maybe they didn't have a schematic and didn't realize there was a capacitor hiding inside that transformer, or if they just decided to leave it in there, but found they had to put that chicon across there to eliminate the noise because the capacitor in the transformer wasn't doing anything. So we found that it's possible that you can check for that by maybe using a component tester. The one I have, the little M tester, they're not expensive on eBay, and verify that the capacitor was there before we went to the trouble of pulling the thing out and disemboweling it. The thing that was kind of lucky is that the tar that we saw leaked everywhere, I do not believe was the same type of tar that was used inside the capacitor. It was kind of more foamy, if you will. I think it was made more of, just to mount it to the chassis and maybe provide just a little bit of adhesion, but it was not significant, as you saw. And once we got the can to the transformer open, you could see that that tar was actually much more solid, and that was what I was expecting, was holding the whole thing on. So that was really good news from that standpoint. And the other good news is that we were able to find that capacitor was just right there on the surface, so we could pop it out, terminate the line, and get this thing back together again. And we tested it, and it works great. So I think this is pretty interesting from that standpoint, and it's nice that we didn't have to depot that thing for sure. You always run the risk of doing that. Okay, so we are almost done with this radio. There's a couple more things I want to do. I think we're going to be able to do it all in one last video. I don't think it'll be long, so stay tuned for that. What I'm going to be addressing is I'm going to be looking at the on the IF tube. It had a variable cathode bias resistor on there. I thought it'd be interesting to see how to set that. That's called the sensitivity control. I have looked all over the internet as best I can, I think, and I have not been able to find instructions on how you're supposed to set that. And so we'll take a look at that. And then also, when we got the tubes, the fellow shipped us a solid state rectifier that we've been using, and we'll look into that, see what it was he did, and whether we're satisfied with that. And then I think we're done with this radio. So stay tuned for that next part. And I really appreciate you guys watching these videos. They're all kind of an adventure for me, and I appreciate all the kind comments. So thanks a lot. Talk to you later. Bye.